Hi, boys and girls, and welcome to Dividing Decimals. This is Chapter 5 in your Go Math book. During this chapter, in this chapter, we will be using quite a few of our math practices. Of course, we will be thinking about what makes sense. We will be persevering in problem solving. Of course, we will attend to precision, always checking our work, and we'll make use of patterns and connections between numbers. So our scale says the students will explain patterns in the placement of the decimal point when a decimal is multiplied or divided by a power of 10. Our goal is to explain patterns in the placement of the decimal point when the decimal is multiplied or, as we're focusing on the most, divided by a power of 10. If I am ready for this chapter, I can notice the patterns that are important in the placement of the decimal point, especially when we are multiplying. And if I'm a 1, I can simply divide whole numbers. Let's take a look at some patterns. Now you're probably thinking, oh man, I know how to multiply using powers of 10, but I'm not so sure how to divide using powers of 10. Well, guess what? We can use what we've learned about the order or the inverse operations to help us. So if we see that we have 456 divided by 10 to the 0 power, let's use what we already know. Well, 10 to the 0 power is 1. So I actually have 456 divided by 1 equals some unknown number. Based on what I know about fact families and the inverse operation between numbers, I know that these two numbers in the equation are actually factors. So if I were to rewrite this, I would say, okay, 1 times some unknown number equals 456. Now, what if I thought about this as, I am thinking about it as a multiplication equation. Well, 1 times what equals 456? You're exactly right. 1 times 456 is 456. Therefore, 456 divided by 10 to the first power is 456. Let's look at the second one. Remember, our strategy is to use inverse operations to help us think about this problem. 456 divided by 10 to the second power is the same thing as some number times 100 equals 456. What number times 100 equals 456? Well, if I move my decimal point 2 times to the left, that's 4.56. Is that true? 4 and 56 hundredths times 100 equals 456. Yes, that is true, because I would move the decimal 2 times to the right, and that would give me 456. 4.56. I bet that I could keep going with this pattern. Okay. What if I was looking at a larger number, or if the numbers weren't written as powers of 10? I would do the same thing, because we know that the powers of 10 are represented by the zeros. Now, I know this is the I do, but I bet you guys are so good at this that you're going to pause the video right now and try it on your own. Okay, so you see we've completed the rest of this chart, and notice that our decimal point places correspond, or they match, the number of zeros in the number that's written for the power of 10. For a moment there, boys and girls, I completely forgot what I was going to say. But yes, you can see that the decimal places match the number of zeros and the number that we're dividing by. Let's look at this algebraically. which means we're going to use algebra. 987 divided by n equals 98.7. What can I ask myself? If I wanted to, I could set this up as a multiplication problem to make it easier for me to see. So n, which is our unknown number, times 98.7, or 98 and 7/10 equals 987. Now I can say to myself, how many times did I move the decimal point to get the product? I moved the decimal point once to the right, which means I moved the decimal point, like I said, once to the right, and that means that I increased by 10. That matches our pattern. So that means that this is 10 to the first power. So let's rewrite this as 987 divided by 10 to the first power equals 98.7. And our quotient is here, 98 and 7/10. Why don't you try the redo and then check your answers? If you would prefer to do the we do together, then you shouldn't pause the video. If you'd like to try it a few times on your own before the you do, then you should pause the video now. Okay, let's use what we know. Our strategy, again, is to use the inverse operations to help us think about this and to help us identify the pattern. Once we think about it in the inverse, it'll be a lot easier for us to just look at the problem and start moving the decimal point. But at first, it was a good strategy to think about this as multiplication. So, some number here times 10 to the 0 power equals 112. I wonder what that number would be. Well, of course, we're multiplying by 1. So the quotient is 112. Now we have 112 divided by 10 to the second power equals blank. Well, what number times 10 to the second power equals 112? Now, notice I skipped 10 to the first power in our pattern. So it's important to notice that. I skipped that on purpose just to make sure that we're paying attention to what the exponent is and not just writing the numbers all the way down on the blank lines. So 10 to the second power times what equals 112? If you are thinking that we need to move the decimal point 2 times to the right, you are correct. Now we have 112 divided by 10 to the third power equals some number. So I'm asking myself, what number times 10 to the third power equals 112? I move the decimal point 3 times. Then I'll move the decimal point 4 times. Then I'll move the decimal point, oh boy, 5 times. And these are the numbers that I have. These are my quotients. The same we will do with the numbers on the other side. Please remember that the number 1 is the same thing as 10 to the first power. 10 is the same as 10 to the first power. Oh dear. 1 is the same as 10 to the 0 power. Please correct that, Miss Addison. Okay, let's try these numbers on the other side. We should have 899,678. Here we should have not quite sure what that number is yet. We have 89,967 and 8/10. Wow, say that 3 times really fast. Here, I'm going to write down all of the digits Then I'm going to count back 2 times and place my decimal point because there are 2 zeros in 100. And then I'm going to count back 3 more times to place the comma. We have 8,996 and 78 hundredths. Let's write the digits again so that we can move the decimal point. 1, 3, 4. Oh, nope. We're only moving it 3 times this time. Let's try that again. 1, 2, 3, 4. Oh, here, and we don't need a comma. We have the number 899 and 678,000. Wow, what a large number behind the decimal point. Now we will move the decimal point 4 digits. We have 89 and 9,678 10,000ths. Wow, say that 3 times fast, boys and girls. Now let's take a look at our division problem where we're using algebra. 776 divided by n equals 7 and 76 hundredths. I wonder if I can rewrite this as multiplication. N times 7.76 equals 776. How many times did I move the decimal point, and in which direction did I move the decimal point to get 776? Well, I had to move the decimal point 2 times to the right, which means I'm multiplying by 10 to the second power. So 776 divided by 10 to the second power equals 7 and 76 hundredths. Now it's your turn to try it on your own. This is a good place to pause the video. Okay, boys and girls, this is your opportunity to take a moment and check your answers, and then take a look at our scale to see where you are. Okay, take a look at the scale. Remember, our goal is to be here. If I'm a 3, I did my practice problems and they were correct, and I'm able to do written proof or understanding. Written proof would be, for example, writing the inverse operation. If your practice problem was wrong and you understand why, then you are a level 2. Or if you just say, you know what, Miss Addison or Miss Walker, I need more practice. And finally, if your practice problem was wrong and you're really not sure why, then you're probably a level 1. Go ahead and mark where you are on your scale. And thanks for watching.